All right, so some of you I saw were doing that. Well, I just wanted to go through this with you together. What do we do with 1 and 2, these exponents? We add them, right? So we got x to the 7th and y to the 6th, right? What do we do when it's division? You subtract them. Now, where's the higher exponent on the left? Above. So when I subtract them, the x to the 4th stays up top. What about the one on the right? The bottom. So when I subtract them, the y to the 3rd stays in the bottom. What's on the top then? A 1. Very good. You guys remember how to do that stuff, right? Okay. We're going to have to do some factoring. All right. So when we did factoring, I gave you this, the steps. You always look for a what first? GCF. The next thing I always look for when I go through a factoring problem is a difference of squares, okay? And a difference of squares are two terms that are both perfect squares, and it's subtraction between them, right? And then we made two sets of parentheses. We took the square root of the first term and put that in the front of both sets. And the second number, we took the square root of that, put it in the back of both, and then what do we do? One's addition, one subtraction, okay? The sum or difference of cubes was when we did, first of all, they had to be two terms, both cubes, could be addition or subtraction. Cubes are to the 3rd power, right? So any variable to a multiple of 3 power, 3, 6, 9, 12 power. Okay, and numbers like 1 cubed is 1, 2 cubed, 8, 3 cubed, 27, 4 cubed, 64, okay, 5 cubed, 125. So those are the type of numbers we look at. And when we factored those, we had a binomial, which was the cube root of both of those numbers, and the trinomial, where we used the first term, we squared it, the middle term, we multiplied the 2, and the last term, we squared it, okay? We won't see very many of those. Probably won't in this section. The perfect square trinomial is when the first and the third were positive perfect squares. And then we did our 1, 2, 3 test. Regular trinomials, we're going to see lots of those. Okay, that's when we looked at the third term, factors, whatever gave you the middle term when you added them. Okay, and then groupings when we had 4 or more. You probably won't see any grouping ones either. The main ones you'll see on this section would be regular trinomials. I wanted to make that red. Regular trinomials, difference of squares, GCF stuff. Those are the 3 basic ones you'll see in this section. Okay, so when we go back to here, right, this is a regular trinomial. What's the A value? 1. What's the B? -2, and the C, -8, right? So when it's a value of 1, which most of ours will be, we can just put x times x for x squared, right? And all we're thinking about are factors. What times what gives me -8, that when I add those two factors, I get -2. And that would be a -4 and a +2, right? Okay. Here, we're supposed to look always for what in the beginning? GCF, which is x. And then what's x squared divided by x? X. And what's -5x divided by x? -5. And then here, what's GCF? X cubed. What's x to the 5th divided by x cubed? X squared. We subtracted. Good. What's -9x cubed divided by x cubed? -9, but what do you notice? Difference of squares, right? So we got to go another step. Square root of x squared, square root of 9, plus and minus. Okay, so that's the main things you're going to see when we do these rational expressions. Okay, so I just wanted to go through that with you quickly, but it's something we've already done, but we're using it to help us do what we have to do today. Okay. All right, so we're going to simplify rational expressions. I'm just going to work on this part today. Tomorrow we'll multiply and divide them, okay? We'll break it up into 2 days. Okay, so we just went through that already. All right, so last section, you worked on inverse variation functions. Remember y equals k, with the various inverse, y equals k divided by x, right? So y equals 5 over x is one of those inverse variations. The expression on the right side of this equation, this 5 over x, is called a rational expression. A rational expression is a quotient, meaning division, or fraction of two polynomials. Here's some more examples of rational expressions. And what we're going to do is we're going to simplify these. We're going to put them in lowest terms. Okay, just like we do all fractions, we always want to write them in lowest terms or simplest form. All right. So because rational expressions are ratios of polynomials, you can simplify them the same way as you simplify fractions. It says, recall that you write a fraction in simplest form, you can divide out common factors in the numerator and denominator. So what they did with 9 is they factored it into 3 times 3, and in 24 they factored it as 8 times 3. Well, you have that 3, same factor top and bottom, you can cancel those. So you can cancel factors, all right? You can't cancel terms. Factors are things that we multiply, right? Terms are things that we add or subtract. So pay attention to that. If this was 3 plus 3 and 8 plus 3, I couldn't cancel those 3's. It has to be multiplication. They have to be factors to cancel them, all right? So that reduced to 3/8. Okay, you're taking out a common factor. It says when identifying values for which a rational expression is undefined, so you're going to have to do this part, identify the values of the variable, the x usually, that make the original denominator equal to 0, right? So if I have an answer, when I solve, well, we're not solving any yet, but if I have a number that I plug in for x and it makes the denominator 0, I can't use that number, okay, as for that variable, okay? We can't have 0 in the denominator, okay? So it says simplify. So this is already factored. Now, if I factor this out, okay, they might have done this already for me, all right? No, they did, all right. So if I factor it out, that's 2 times 5 times x. 1, 2, 3, 4, 5. All right. And then 6, 2 times 3. Now you don't have to do this, but this is what we're doing. All right. Those are factored out, right? So you can cancel that factors that are the same. Okay, so our answer is 5x to the 4th over 3. That's simplified. Now normally what we do is, where's the higher exponent? Top. So where's the x going to stay? Top. And how many are going to stay up there? 4. You just subtract, right? What number goes into both of these? 2. So normally we'll just go, 2 goes into that 5 times, 2 goes into that 3 times. Those cancel. Gives me 4 of them. Okay? But I wanted to show you factored out, because when we get to the, x squared plus 2x minus 4, we're going to have to factor first. We can't just start canceling stuff. When it's all multiplication, we can just go ahead and cancel stuff. Does that make sense? It says identify any x values for which the expression is undefined. So that's what makes the bottom equal to 0. That's what I'm identifying. So how do I solve for x here? Good. What's 0 divided by anything? 0. So how do I get rid of the 4 exponent? What if it was a 2 exponent? What would I do? Square root. So it's a 4 exponent, I do 4th root. Okay? So I do. Well, any root of 0 is going to be what? 0. So the restriction is for this is x cannot be 0. That's what we call it. I call it restrictions. That's when it's undefined. All right? It's undefined at x equals 0. So I just write usually right by our answer, we put whatever the x value is not allowed to equal. That's what I call restrictions. That's what makes the denominator 0. Okay? So the simplify part is that. Identify, that's that. Okay? So far, so good. All right, now, I can't just say, oh, there's an x squared, boom, I can cancel it. It's not a factor right now. The x squared is a term, right? Because it's addition and subtraction. So I have to factor, all right? Is there a GCF for the top? No. So it's got 3 terms, so it's one of those regular trinomials, okay? Do they have it? Yeah, they have it done. Okay, so when factors of -2 that add up to 1 is a +2 and a -1, right? 2 times -1 is -2, and 2 plus -1 is 1, right? So that's where they got that. Did the 3. Factors of -3 that give you +2 would be those 2, right? When you multiply them, it's -3, but when you add them, you get 2, right? Now, these x minus 1s, these factors, that whole thing, I can cancel. So once it's factored, when you get factors that are the same top and bottom, cancel them. So our answer, simplified, reduced, is x plus 2 over x plus 3. Okay? Does that make sense? So factor first when you have addition and subtraction. Then cancel factors. That'll be the same top, bottom. Now, what makes it undefined? It's the original expression. It's this. So you look at both of these. What value of x makes that part equal to 0? Just this bottom part red here. What makes that equal to 0? What number do I put in for x to make this equal to 0? +1. What number for x makes this black one equal to -3? All right, so my restrictions are x cannot equal 1 or -3, which they'll tell us here underneath. Okay. So again, I just put x cannot equal and then what they are. And it's the original one. It's not after you've simplified it. It's over here before you cancel. Okay? So a lot of times there's more than one number that makes it undefined, because that gives us 0 in the denominator. Any questions on that example? So again, what you're going to do, you're going to get in a hurry, because you're going to see some like this, and you can go right ahead and start canceling. And then you'll get to one like this, and you say, oh, I can just do this. And say, well, that's probably what, a -1 over -3, so just 1/3. No, you can't do that. Don't do it. Don't you do it. All right? All right, they're just checking. Plug it in 1 and plug it in -3, and they see that you get 0 in the denominator. You don't have to do that part. All right, you guys go ahead and do that one. It's kind of hard to see, but that's an x squared. No. You should be done in about a minute or less. Car, you're already done, huh?
Yeah.
Good. Grace, you done? Nice. Looking better today. You're looking more awake today. You didn't need to go further. But you're right so far. Yeah, right.
So all I'm
Whenever I work on those, once I get home, I'm still in my like go energy,
first 30 minutes practice. So
Trent, what'd you get? 2x to the 9th, he says. You guys agree with him? You sure? Yeah, it was Trent we're talking about.
Wow.
He knows I'm messing with him. Very good, sir. All right, so 8 goes into 8 once. 8 goes into 16 twice. So 2 up top. You can put the 1 in the bottom if you want. You don't have to, but that's okay. And then what do you do with the exponents? Subtract. Where does the x stay? Top. Why? Bigger exponent, right? Restriction? What's x not allowed to equal? Yeah, 0. Whenever there's no addition or subtraction, and there's a variable in the bottom, it's just going to be 0. So don't forget about that part, right? Identify and the expressions that you're trying to find. Okay? There we go. All right, try that one. Oh! Here, well, I'll do this one with you, because it's what's going to mess you up? What's the A value down here? 3. When it's 1, it's real easy, right? So here's what we do when it's 3, right? We multiply those two numbers. What's 3 times -4? -12, okay? So we're thinking of, we could use 3 and -4, or -3 and +4. We could use 2 and -6, or -2 and +6. We could use 1 and -12, or -1 and 12, right? Those are the 6 possibilities, right? Now, which possibility do we want? What are they supposed to add up to? +1. So is it this one or this one? This one, right? We good with that? Now, I can't just put, negative, well, I kind of do, but I can't just say, because that 3 there, I got to do a little more work, right? So I rewrite it as 3x squared. And then I use, instead of plus x, I use negative 3x plus 4x. And then the minus 4. Okay, so I turn it into what type of problem? Well, it is a quadratic because it's x squared, but how many terms are in there? So we call it grouping, remember? That last one. Okay? So I'm going to group these two, and take out the GCF. What's the GCF between those two? 3x. What's the GCF in these two? 4, right? What's 3x squared divided by 3x? X. What's negative 3x divided by 3x? Negative 1. What's 4x divided by 4? What's negative 4 divided by 4? What do you notice about the blue thing? They're the same. Isn't that what we want to happen? Yeah. Okay, so that's one of my factors. What's my other factor? Right, 3x plus 4. Do you see any factors that are the same? 3x plus 4. So I can cancel the 3x plus 4s now. Now, if everything cancels up top, what number is there? 1, not 0, 1, right? So our answer is 1 over what? X minus 1. What are my restrictions? Positive 1. What makes that 0? What makes that 0? What would I do first to solve? Subtract 4 and then? Right. So subtract 4 and divide by 3, right? So there's my 2 restrictions. And it's there. Okay? So if you when it's like this, it's real easy to tell what it is, right? When it's like that, you got to maybe think a little bit more. But if you're not sure, just do that and solve for x, and it'll give you the number. It's not allowed to be. Okay? That one makes sense? Questions? You sure? Okay, so remember, when we see pluses and minuses, we have to factor it first. When there's no pluses or minuses, we don't have to worry about it. It's basically already in factor form, right? They just checking. All right. Okay, so they already did this one. All right. You won't get one this hard, I don't think, for quiz or homework. But again, you could do 6 times 2, 12. And then you'd use 4 and 3 for the 7, right? And then 6 times negative 6 is negative 36. So you would use negative 9 and a positive 4 and get your negative 5. But this is already factored out, so we get a 3x plus 2 that were the same, so we can cancel those, right? So again, my restrictions, what's going on? I want it right. Oh, well. Well, my restrictions would be, subtract 2 divided by 3, negative 2/3. Add 3 divided by 2, positive 3/2. I don't know why it wouldn't let me write there for a second. Okay? All right, now they're going to try to mess with you now. All right, watch this one. Kennedy, you watching? All right, what's going on with this? I don't know what's going on here right now. All right, that worked. Okay. All right, so what's going on up here? You know, that, they put it in the wrong order. You're used to seeing x squared out front, right? So the first thing you want to do is switch it into the order that you're used to. Also, what's going on here? There's a negative, okay? So sometimes they're going to change the order up on you, so put in the right order. Sometimes they'll do both of these things. Make your x squared negative. Okay, if your x squared is negative, factor out that -1. It'll make your factoring life much easier. Much easier when the x squared is positive like we're used to. That's what they did. They changed the order and factored out that -1. So negative x squared divided by -1 makes that a positive x squared, which we like. And that positive 4x divided by -1 made that a negative 4x. Okay? Well, this has a GCF of x, so we got our -1 still. Don't forget about it. Pulled the x out. X squared divided by x gave me x. -4x divided by x gave me the -4. So the top got factored like that. The bottom is an easier one because there's no GCF and a is 1, so we just worry about factors of -8 that add up to -2, which are -4 and a +2. So the x minus 4 is canceled. So my answer is -x over x plus 2. Okay? Now we look here for our restrictions, right? What makes that 0? +4, what makes that 0? -2. So those are my two restrictions, which they have here. But again, I always just write it here. +4, -2. I just put it right next to it or under it. Right, Colin?
Yeah.
So, they're gonna mess with you. What were they doing to mess with you? Had one of them out of order. Also, what else? Negative x squared. Okay? So make sure it's in the right order and pull out that -1. Okay? So they did that again here. They didn't have the order wrong, but they had the -1, right? So you pull out the -1, and then this factor, 2 times 3 is 6. And when the third one's positive, you look at the middle, they're both negative. So -1 and -6, or -2 and -3, which two add up to -7? The top one, right? So we would have rewritten this as 2x. Let me write there, huh? If I can write down here. No. Down here? No. I don't know what's going on. Oh, well. I would have rewritten that as 2x squared minus 1x minus 6x plus 3 and grouped it, but you would have ended up with this after you grouped it. Okay? So what happened is you got an x minus 3 top and bottom, so you could cancel them. So you get the -x up top and the 2x minus 1 on the bottom. My restrictions are what? 3. When I do it to 1, if I had it equal to 0. Add 1, and then what? Divide by 2, so it'd be, not subtract 2, well, divide by 2, 1/2, right? Which they have here. That? Yeah. Okay? Question? I think that's the last example. Yeah. Okay? So 2 through 7 and 18, 19, and 20. They're all simplifying these rational expressions, these polynomial fractions. Okay,
You're asking for